For this problem, we'll follow the same 7 steps that we did in the previous problem. We'll begin by trying to write a claim. This question says that California boasts that more than 9% of homes have solar panels to generate electricity. In a random sample of 120 homes from California, 15 have solar panels. The claim we are trying to test, according to Part A, is that the proportion of homes that have solar panels is more than 9%. They also give us a significance level to use. Now, let's read this claim. We're going to be using proportion, and proportion is represented with a little p. More than means greater than, and 9% can be represented by 0.09. Now remember that greater than, less than, and not equal to will feed into the alternate hypothesis H1, whereas greater than or equal, less than or equal feed into the null hypothesis, or H0. Since we have greater than in this case, this means that the claim will be the alternate hypothesis H1. So we'll write we have a claim, write that it's H1, write the letter little p greater than 0.09. This means our null, according to step 2, will be the opposite of greater. That would be less, but remember that null must also contain equal to. We'll use the same letter and the same number. Now let's think about our possible outcomes. Now, if our big P is less than or equal to alpha, that means we would reject the null hypothesis. So imagine we crossed out the null hypothesis. That means what would be left over is the claim. So in rejecting the null hypothesis, we would be supporting the claim. And we would be supporting the claim because our evidence is strong enough to support the claim and reject the null. Our other outcome would be if our big P is greater than alpha. Now this means our evidence is not strong. Because our evidence is not strong, we fail to reject the null. We can only reject the null if the evidence is strong. Now, in failing to reject the null, we would have to keep the null. We would box in the null, but we could not box in the claim. So we cannot support the claim. The reason we can't support the claim is we don't have the evidence to do so. That takes care of step 3. Now we calculate the test statistic. Now for proportions, our test statistic, z, is equal to p hat minus p divided by square root of p multiply q divide n. Remember that p hat is your sample proportion, and p without the hat is your claim proportion. So we have to make that distinction as we enter our data. So let's have a look at what we were given in the question. Now, in our sample, we have 120 homes and 15 have solar panels. So we can say our x, that is the number that do have solar panels, is 15. Our n, the total size of the sample, is 120. So our p hat, we would take x divided by n. So we'll say equals 15 divided by 120. This gives us our p hat. Whereas our p without the hat will simply be the claim that we wrote previously. In the claim we have 0.09, therefore we'll simply write that as our p. Now our q is always going to be 1 minus p. So we'll calculate that next. And we get 0.91. Based on all this, we can now calculate the test statistic z. Put parentheses, p hat, subtract p. Close the parentheses and divide by a square root of p multiply q, divide by n. With all 5 numbers in place, we press enter, and we get our test statistic. That takes care of step 4. We'll paint that cell gold, and move to step 5. Step 5 says to calculate the big P. Now, to calculate the big P, we must first examine what type of test we are doing. Now, remember to look to the alternate hypothesis to tell what type of test we have. If the alternate hypothesis says less than, that means we have a left tail test. If it's greater than, we have a right tail test. And if it's not equal to, we have a two-tail test. Now, because it says greater than in our alternate hypothesis this time, that means our test will be right tail. Now, if it was left tail, we would use equals norm S dist of the z-score, comma true, to find our big P value. Since it's right tail, we take 1 minus that. Now, if it was two tail, we would use 2 times whichever of the tails is smaller, and we would take the minimum of the left and the right. We'll run through all 3 calculations, but we really only need the right tail here. So we'll enter a field for P left, P right, and P two-tail. We enter equals norm S dist, click on the z, comma true. Then for the right tail, we take 1 minus that, and for the two-tail, we take 2 times whichever of the 2 is smaller. We'll say min and select both of them. But we'll paint the right one gold because that's the one we actually want. That takes care of step 5. We've calculated our big P. Now we compare it against alpha. Now our big P we found was 0.0902. And our alpha was 0.1. Therefore, our big P is less than alpha, which means the option we select is the first option. We have strong enough evidence, based on this significance level, to reject the null hypothesis. So let's cross it out, and let's box in the claim. So what we'll say is that we have strong enough evidence to reject the null hypothesis and support the claim. That takes care of step 6, and so now we'll restate our decision. The claim that was made was that more than 9% of homes in California are using solar panels. So we'll say there is strong enough evidence at this significance level of 0.1 to support this claim that more than 9% are using solar panels. So the key phrases here are this one, where we're saying there is enough evidence and that we're supporting the claim. It also doesn't hurt to mention the significance level again and restate the claim again.